Good afternoon, everybody. Myself, Chirag Lalit Bafna. I am from third year Electrical Engineering Department. My roll number is 34002. Today, I am going to discuss about some LCD interfacing, ADC interfacing, and LM35 interfacing with PIC18F458 microcontroller. This section describes the operation modes of LCDs. Then describe how to write the program and interface an LCD to a PIC18 microcontroller. In recent years, the LCD has been finding the widespread use replacing the LEDs, 7-segment LEDs or other multi-segment LEDs. This is due to the following some reasons. First one is declining the prices of LCDs, the ability to display the number, characters, and graphics. This is in contrast to LED, which are limited to numbers and a few characters. Incorporation of a refreshing the controller into the LCD, thereby relieving the CPU of the task of refreshing the LCD. It's easy of programming and ease of the programming for characters and graphics too. So what do you mean by LED or LCD? See, LED is a light emitting diode, whereas LCD is a liquid crystal display, is a flat panel display that uses the light modulating properties of liquid crystals. Liquid crystals don't emit light directly. Here are some pictures of LCD. This is the block diagram of LCD. We have given three control signals, that is RS, RW and E. These three control signals given to the control unit and command register and data register are inbuilt over here. After that, we take the output from the DD-RAM through VCC, VDD and VSS. Let's discuss about this parameter. See, RS is a register select. When RS equal to 1, that means the data register is selected. When RS equal to 0, that means the command register is selected. RW is a read and write. When RW equal to 1, that means it reads the data from the LCD module, and when RW equal to 0, then LCD write to LCD module. EN is a enable, which is high to low logic. Logic equal to 1 and delay logic equal to 0 for use the LCD module. There are three memorized in LCD to manipulate the display characters. CG-ROM, that means character regenerating ROM, which is responsible for stored standard character pattern. After that, there is a CG-RAM, character regenerating RAM, which holds the custom character pattern. The space of this LCD is total in 8, that means 16 by 2 module is there. DD-RAM, that means data display, which stores some ASCII codes. Here is the interfacing diagram of the LCD. As we know that VSS is a ground, VCC is a 5-volt power supply, VEE is a power supply to control the contrast. Here two oscillator is there which connected the switch and resistance and some pins of the LCD. DB0 to DB7 is a 8-bit data bus. There are two very important resistors inside the LCD. The RS pin is used for their selection as follows. If RS equal to 0, the instruction command code register is selected and it allows the user to send the command such as a clear display, cursor at home and so on. If RS which is equal to 1, the data register is selected, allowing the user to send the data to be displayed on the LCD. After that, we can see the LCD display. Here are the operating parameters. First one is a ground. After that, supply voltage, contrast adjustment, low to write register, high to read from the register. And as we discussed, DB0 to DB7 is the 8-bit data bus. Following are the steps to understand how character display. Control unit of LCD receives the signal. Basically, it is ASCII code from user and asks to data display, that is DD-RAM for its match. After that, if ASCII code match, the control unit maps the corresponding character pattern from CG-ROM. According to that character pattern, LCD screen energized and we can see all characters on it. Here are some working of LCD command. First one is a clear display return. After that, return home, decrement cursor, increment cursor, shift display right, shift display left, and so on. Second one is the ADC, that is analog to digital converter interfacing with PIC18F458. Explores the more real-world devices such as ADC, DAC, and sensor. We will also explain how to interface the PIC18 to these devices. We will program the ADC portion of the PIC18 chip afterwards. This section will explore the ADC programming in PIC18 chips. First, we describe some general aspect of the ADC itself, then show how to program the ADC portion of the PIC18 microcontroller. Analog to digital converter are among the most widely used devices for data acquisitions. Digital computer use the binary values, but in the physical world everything is analog, that is continuous. Temperature, pressure, humidity, and velocity are few examples of physical quantities that we deal with every day. A physical quantity is converted to electrical signals using a device that is called a transducer. Transducers are also referred as to sensor. Sensors for temperature, velocity, pressure, light, and many more. Therefore, we need an analog to digital converter to translate the analog signals to digital numbers so that microcontroller can read and process them. PIC18F458 ADC having some features. First one is obviously it is analog to digital converter. It converts the voltage into corresponding digital value it use in the data acquisition system. It's a on-chip ADC. PIC18F458 has the 10-bit 8-channel A to D converter and the number of analog input varies among the differences PIC18 devices. Following are the register which is included in the AD converter. First one is a ADRESH, that is high resistor. Second one is ADRESL, that is low resistor. ADC on 0, that is control resistance register 0 and control register 1. First two register hold the result of the AD conversion and gives the 16-bit output, whereas ADC on 0 is a control register used for setting the conversion time as well as it used to select the input channel. ADC on 1 is a control register used for the setting V reference voltage. For example, or if we take 5 volt, then input varies from 0 to 5 volt and stepwise millivolt will get 19.53, that is 5 divided by 256. Step size is V reference divided by 256 because it is an 8-bit ADC and 2 to the power of 8 gives as 256 steps. So 5 divided by 256 equal to 19.53. And if we take the range of 10-bit ADC, then your step size will be changed. 5 divided by 1024, which is equal to 4.88 millivolt. Here is the interfacing diagram of analog to digital converter. The D0 to D7 data pins of the 8-bit ADC provide an 8-bit parallel data path between the ADC chip and the CPU. In case of 16-bit parallel ADC chip, we need the 16 pins for the data path. In order to save the pins, many 12 and 16-bit ADC use pin the D0 to D7 to send the out upper and lower byte of the binary data. In recent years, for many applications where space is critical issue, using such as a large number of pins of the data isn't feasible. For this reason, serial devices such as the serial ADC are becoming widely used. While the serial ADCs use the fewer pins and their smaller packages take much less space on the printed circuit board. More CPU time is needed to get the converted data from the ADC because the CPU must get data one bit at a time instead of in one single read operation as with the parallel ADC. Many data acquisition applications needs the more than one ADC. For this reason, we can use ADC chip with 2, 4, 8 or 16 channel on a single chip. Multiplexing of an analog input is widely used as shown in the figure. In this chip, we have 8 channels of analog input allowing us to monitor multiple quantities such as temperature, pressure, heat, and so on. PIC18 microcontroller chips come with the 5 to 15 ADC channels depending on the family member. The fact that we have multiple analog input channel and a single digital output register makes it necessary for start conversion, that is SC, and end of conversion, that is EOC signals. When SE is activated, the ADC starts converting the analog input value of V into an n-bit digital number. The amount of time it takes to convert varies depending on the conversion method, as was explained earlier. When the data conversion is complete, the end of conversion signal notifies the CPU that the converted data is ready to be picked up. Here I am taking the C programming for the ADC PIC18F458. We should mention preprocessor directive, that is hash include PIC18F458H, unsigned integer ADC void main void ADC on 1 0x18, we give some value, trace A declare as a Input port tree C declare as output and trace B equal to 0, that is port is output. So we are providing some loop, that is do while loop. When ADC equal to ADC read, that means 1, it get 10-bit result of AD conversion of channel 1. After that sends the lower 8 bit to port B and send two most significant bits to RC7 and RC6, which is output, while one is needed if we run in the software. While one is needed if we run in hardware, and while 0 is needed when run in software. Third one is measurement of temperature and voltage. Temperature sensor of LM35 is an integrated circuit sensor that can be used to measure the temperature with an electrical output proportional to the temperature in terms of degrees Celsius. The LM35 devices has an advantage over linear temperature sensor calibrated in the Kelvin, as the user is not required to subtract a large constant voltage from the output to obtain convenient centigrade scaling. The LM34 requires no external calibration because it is an internally calibrated. It output 10 millivolt for each degree of temperature, but here we are using LM35. Its series sensors are precision integrated circuit temperature sensor whose output voltage is linearly proportional to Celsius, that is centigrade. The low output impedance, linear output, and precise inherent calibration of the LM35 device makes the interfacing to readout and control circuitry especially in easy way. The LM35 requires no external calibration. Signal conditioning is widely used in the world of data acquisition. The most of the common transducer produce an output in the form of voltage, current, charge, capacitance, and resistance. We need to convert this signal to voltage. However, in order to send input to an A to D converter, this conversion is commonly called signal conditioning. See in the figure, signal conditioning can be a current to voltage conversion or a signal amplification. For example, the change of resistance must be translated into voltage in order to be of any use of ADC. Look at the case of this conversion. Here are some parameter, that is resistance and LM35 sensor, and we connect one resistance in parallel with sensor and ground 2. LM35 device is rated to operate over a minus 55 degrees Celsius to 150 degrees Celsius temperature in the range, while the LM35 device is rated for minus 40 degrees Celsius to 110 degrees Celsius range. This is the interfacing of LM35 with PIC18F458 microcontroller. Two oscillator is there. and RB0 to RB7. These are the 8-bit data bus to transfer the data towards the display. LM35 temperature sensor converts the temperature into proportional analog voltage value. It has the three terminals, pin number 1 and 3 for the 5-volt supply, and pin number 2 is analog voltage output with respect to temperature value. Hence, for every 1 degree increase in a temperature, there will be an increment of 10 millivolt in the output voltage of this sensor. PIC18F microcontroller built-in ADC is used to measure analog voltage. After that, it having 7 built-in ADC channels. After reading the value using voltage and temperature relationship, voltage is converted back into the temperature. A conversion factor is used to convert the voltage back into temperature. All this conversion has been done through programming. LCD is connected to port B of the PIC18 microcontroller to display output. We had already performed the practical on hardware kit. Thank you. With the deep sense of gratitude, I would like to thank Rajni ma'am for giving me this opportunity. Thanks to all.